Welcome aboard Talfa. I'm Captain StiK, joined by the legendary Captain YoK, to navigate you through the skies of aviation knowledge. And for those quick must-knows, our Talfa bot is always on standby. So sit back, relax, and let's take off. All right, so have you ever looked up at a plane and wondered why they just can't keep going? All the way into space?
Oh, yeah, all the time. I mean, It seems so simple, right?
Right, it's like they're already up there, so what's stopping them?
Well, as it turns out, a whole lot, actually.
You're kidding. So we're going to do a deep dive today into all those reasons why airplanes just can't fly into space, no matter how much we wish they could. We've got explanations, we've got stories, and we even have a few examples that might just surprise you.
It's a much more complicated topic than most people realize.
Totally. So let's just start with the basics. When we think about how planes fly, that whole idea of lift, how does that even work? And why does it become such a big deal when we're talking about space travel?
So lift, it's all about the wings and the way they interact with the air. The shape of the wing is designed to make the air flowing over the top move faster than the air underneath. And faster moving air creates lower pressure.
Okay, so that's the whole Bernoulli's principle thing.
Exactly. And it's that difference in pressure, the lower pressure above the wing and the higher pressure below, that creates the lift that keeps the plane in the air.
Gotcha. But how does air density come into play here?
Well, imagine trying to swim in water versus trying to swim in honey.
Ooh, that's a sticky situation.
Exactly. Honey is way denser than water, so it's much harder to move through. The same thing happens with air. The higher you go, the less dense the air gets. So the wings have fewer air molecules to push off of.
So less air means less lift.
Precisely.
Right.
And at a certain point, the air gets so thin that even the biggest, most powerful planes just can't generate enough lift to stay up.
So basically there's an invisible ceiling up there that planes just can't break through.
You could say that. And that's just one of the many reasons why flying into space is so much more complicated than it sounds.
All right, so we've hit our first roadblock. But hold on. We got engines too, right? Planes don't just need lift, they need to move forward. So what happens to those powerful jet engines when we try to take them into the vacuum of space?
Well, jet engines need air to work. They take in air, mix it with fuel, ignite it, and the expanding hot gases shoot out the back, creating thrust.
So it's kind of like a fire needing oxygen to burn.
Exactly. No oxygen, no fire. And in space, there's no air. So even the most powerful jet engine would just sputter and die.
So even if we figured out how to get enough lift up there, our engines would just quit on us.
It's not that they quit. It's more like they were never designed to work in an environment without air.
Okay, so 2 strikes against flying a plane into space. Not enough air for lift and no air for our engines to breathe. But I'm guessing there's even more to this story, right?
Oh yeah, we're just getting started. There's a whole lot more to unpack. So we've talked about air, or rather the lack of it being a problem for both lift and engine. But let's say just for a minute that we could somehow wave a magic wand and make those problems disappear. Would we be ready to launch our airplane into space?
I'm starting to suspect that it's not going to be that easy.
You're catching on. There's this whole other thing we haven't even touched on yet. Speed.
Speed. Like how fast a plane can fly.
Well, yes, but it's more than that. It's about the speed you need to reach to actually stay in orbit.
Oh, right. Because it's not just about going up, it's about staying up there.
Exactly. To get into orbit, you have to go sideways really, really fast,
Okay.
like 17,500 miles per hour.
Wow. That's way faster than any airplane can go.
Exactly. And that brings us to another big hurdle, fuel.
Ah, yes. Because all that speed requires a ton of energy.
Think about those space shuttle launches. Remember those giant orange external fuel tanks?
Oh, yeah. Those things were huge.
They held hundreds of thousands of gallons of fuel. And that was just to get the shuttle, which is tiny compared to a jumbo jet, into orbit.
Okay, so we're talking about an insane amount of fuel just to get up to those speeds and escape Earth's gravity.
And remember, airplanes are designed to be as fuel efficient as possible. They're not built to lug around massive amounts of fuel.
So even if we could solve the air problem and the engine problem, we'd still need to figure out how to carry enough fuel to reach those crazy orbital speeds.
It's a huge challenge. But wait, there's more.
Oh, no. Starting to sense a pattern here. What else could there be?
Remember how we talked about how the air gets thinner as you go higher?
Yeah, less air, less lift.
Right. Well, as you go higher and the air gets thinner, the range of speeds at which a plane can safely fly starts to narrow.
Narrow. There's a stall speed, which is the minimum speed the plane needs to maintain lift. And then there's a critical Mach number, which is the speed at which the airflow over the wings becomes turbulent and can cause problems. So we have to stay between those 2 speeds.
Exactly. And at high altitudes, those 2 speeds start to get closer and closer together. That's coffin corner.
So it's like a shrinking window of safe speeds. And the higher you go, the smaller that window gets.
Exactly. And if you hit that corner, you're in big trouble. You can't go any faster or slower without risking a stall or losing control. And that's at altitudes that planes can already fly at. Imagine trying to navigate that at the edge of space.
Yikes. That sounds terrifying.
But believe it or not, there's still one more challenge we haven't talked about.
Okay, I have to ask, what is it?
Re-entry heat. It's kind of a big deal. It's something that most people don't think about when they picture flying into space.
I mean, it makes sense, though. You can't just, like, slam on the brakes and coast back down to Earth.
Right. When something comes back into the atmosphere from space, it's hitting those air molecules at incredible speeds, and all that friction creates a ton of heat.
Like those amazing images of space capsules coming back, glowing red hot.
Exactly. Thousands of degrees Fahrenheit.
Wow. And spacecraft are built to withstand that kind of heat. They have those special heat shields, right?
Right. They're designed to absorb and dissipate all that energy.
So what about airplanes? I mean, they're made of aluminum with those, little windows. Would they even stand a chance?
Let's just say a regular airplane trying to come back from space would be like an ice cube in a volcano.
Okay. Yeah, that paints a pretty vivid picture. So just to sum things up, we've got air density limiting our lift and messing with our engines. We've got those insane speed requirements for orbit and the ridiculous amount of fuel we'd need to get there. Then there's that whole coffin corner thing. And to top it all off, we've got the fiery inferno of re-entry.
It's a lot to overcome. And that's why we haven't seen any airplanes flying into space anytime soon.
Right. It's not just a matter of strapping some bigger wings on a jet and hoping for the best.
Exactly. But that doesn't mean we haven't tried to bridge the gap between air travel and space travel. You've probably heard of space planes, right?
Oh, yeah. Those vehicles that are like a cross between a plane and a spacecraft, I always thought those were super cool. How do they work? I mean, how do they handle both flying in the atmosphere and being in space?
It's all about smart design and some pretty incredible materials. Space planes have to be lightweight, but also incredibly strong. They need to be able to handle the forces of taking off and landing, but also the extreme conditions of space.
And some of them have actually flown successfully, right?
Yeah, definitely. The Space Shuttle is a great example. Those orbiters were technically spacecraft, but they came back to Earth and landed like gliders. And then there are things like the X37, which is a smaller unmanned spaceplane that can stay in orbit for long periods of time.
So we're not just talking about science fiction here. These are real things that have been built and flown.
And they're pushing the boundaries of what we think is possible when it comes to space travel.
So maybe someday we'll have space planes that can take off from a runway, fly into space, and then come back and land again.
It's definitely a possibility. Who knows what the future holds?
All right, so we've learned that while regular airplanes are amazing machines, they just aren't cut out for space travel. But that doesn't mean the dream of flying a plane into space is dead.
Nope. It's just a matter of innovation and finding creative solutions to some really tough problems.
Awesome. Well, thanks for joining us for this deep dive into the world of airplanes and space travel. I don't know about you, but I'm feeling inspired to go learn more about space planes and what the future might hold.
It's definitely a topic that sparks the imagination.
Totally. Well, that's all the time we have for today. But keep looking up, everyone, and never stop wondering about the amazing things that are possible.